Question 8. This question is about polymers. Chloroethene can be used to produce an additional polymer called polychloroethene. The display structural formula for chloroethene is this compound here. Question 8.1. Draw a circle around the functional group on the display structural formula that allows chloroethene to produce an additional polymer. The functional group will be the ethene because it's unsaturated. It will be saturated when you add more compound to it. So it's going to add more chloroethene to it. So the double bond will become single bond when saturated. Question 8.2. Complete the equation for the production of polychloroethene from chloroethene. So the chloroethene here is a monomer, and N means many are going to react together. This is unsaturated. It's very reactive. And so the question then is to complete what we're going to get for the product here. And the product will be just a chain of these polychloroethene, because we have N number of the chains. So the N will go down here and the double bond will become single bond. So that's it. And one goes here and the other goes there. And that's what you get here. And this is what you get. So it's going to be the same structure, except the double bond becomes single bond and the N will always go down here, and then you put the single bond, double bond that is broken, one of them, one goes there and one goes there. Question 8.3. Polyethylene can be strengthened with wood particles to make a building material. The building material consists of a wood particle reinforcement embedded in a polyethylene matrix. What general name is given to materials like this? Composites. Question 8.4. The amino acid beta-aniline has the formula. The beta-aniline polymerizes to produce a polypeptide and a small molecule. Name the small molecule produced when beta-aniline polymerizes. The small molecule produced will be water. Just so you know why this happens, this is the structure here. That structure is this. I'll just spread it out a little bit more. I'll do a bit of more display here. And that bit here is this bit here. And so that bit here is this. So what's happening is the H here and the OH here will combine to form water. And then the bond will then form a link here. So that carbon will be linking to that nitrogen there. So you're going to get water, this water being eliminated. And then you form a new bond between carbon and the nitrogen. And that's what you call the peptide link. That's the peptide link here. Question 8.5. An amino acid can be represented by this compound here. So this could be amino acid. This is the base side and this is the acid side. The relative formula mass, MR, of this amino acid is 75 grams per mole. Calculate the relative formula mass of the section of these amino acid molecule represented by that bit here. So you want this bit minus that, minus that. So what we need to do is find out what that is and what that is and take it away from 75 and we get that. So we start off with the relative molecular mass of the NH2, that one, and COOH, this one here, add up to 61 grams per mole. The relative molecular mass of this compound here is 75. So if I want to find that one, the relative molecular mass of this will then be 75 minus 61, and that will give you 14 grams per mole. So we're expecting 14 grams per mole. Figure 6 represents part of a naturally occurring polymer molecule produced from glucose. So here's the polymer molecule. So that's a unit. This is a monomer. This is trimer. Trimer because it's 3 of them so far. And many more would be polymer. 8.6. Draw a circle around the repeating unit of the polymer in figure 6. You can see the repeating unit will be, well, we can see this side here is consistent. So that's a repeating unit. And then the whole thing. So the repeating unit will be that and that. So that will be the repeating unit. Question 8.7 suggests the identity of this polymer. So this polymer will be what we call starch. The identity of this polymer. Starch is many glucose. So that's a glucose, and many joined together is what we call starch. Figure 7 represents the structure of a naturally occurring polymer. Question 8.8. Give the general name for the 4 different monomers which make up the structure shown in figure 7. So the 4 different ones we're talking about will be the CGAT, and they are a makeup of a nucleotide which has a phosphate group, has a sugar group, and the base. So the 4 different base is what makes up these different monomers. And name the shape of the structure shown in figure 7. That is a double helix. That's one helix and the second helix is there, so that's double helix.